Okay, let's talk about numbers and patterns. So, introduction, numbers and patterns play an important role in natural and social sciences. Together, they're used as tools for prediction and analysis to understand trends in science, technology, economics, politics, and other human activities. Examples of numerical patterns include the Golden Ratio and Fibonacci numbers, which are both relevant in nature, beauty, and art, among others. To say the least, numbers and patterns are omnipresent concepts that can give meaning to areas of learning and development. So, learning outcomes natin for this particular uh, module or chapter is describe various numeration systems used by different cultures, explain properties of different structures of numbers, discuss the relevance of modular number systems in daily situations, and describe types of number and geometric patterns. So, numbers, ano ba ang numbers? Numbers, much like letters, are very important to our everyday lives. They are universally understood symbols more so often than letters that are often used to convey mathematical ideas. Dozens of numeration systems emerged in the past, but only a few of these are still used today. Halimbawa, the tally mark system. So ito yung mga numeration system. Ano ang tally marks? Tally mark system is the most basic way of assigning symbols to quantity. Its simplicity is its main advantage, but it is limited when expressing large numbers. This system is commonly used in settings where objects are counted per item, like doing an inventory in a store or counting the score earned by a team in a valuable tournament. In both examples, using the tally mark system is simpler than the Hindu-Arabic system since one could simply increase the marks on the currently displayed tally, whereas using Hindu-Arabic system would require constant modification of the appearing symbol. So basically, ang tally mark system, ito lang alam nating system na yung ginagawa natin ng 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But notice, as it gets bigger and bigger, nagiging cumbersome and inefficient yung system nito. Okay? Next, the Roman numeration system. The Roman numeration system, a scheme devised by the Romans to measure quantity throughout the Roman Empire, still exists today. In this system, letters I, V, X, L, C, D, and M represents 1, 5, 10, 50, 100, 500, and 1000 respectively. Even after the fall of the Roman Empire, the numerals were prevalent in Europe up until the 11th century. In modern times, where the Hindu-Arabic system is preferred, the Roman numerals are the primary symbols to refer to monarch or popes. For example, Queen Elizabeth II and Pope John Paul II. This numeral can also be seen to denote the year of construction in buildings or the hours on a clock. Then we also have the Egyptian numeration system and the Babylonian numeration system. At around 3000 BC, Egyptians had a numeration system which used special symbols called hieroglyphics. Each power of 10 had its own hieroglyph. For example, a bent finger is used to represent 10,000, while a coiled rope is to represent 100. This system does not use a place value type of interpretation, but employs an additive approach. Next is the Babylonian numeration system. The Babylonians inherited ideas for a base 60 system, referred to as the sexagesimal system. Compared to the decimal system we use today, where we have 10 different symbols, the Babylonian system doesn't utilize 60 different symbols to represent its digits. Instead, they have two symbols to represent a unit value and a tens value, which they repeat to express 60 distinct digits in their base 60 positional system. Now, um, if you have studied French language, ang French language ay meron ding sexagesimal system. So, ibig sabihin, for example, they want to write their 60 sa French. Ang 60 sa French ay 40 plus 20. Ang 80 naman ay 40 plus, let me check, katawang, sorry, di pala 40 plus 20. Swasong pala ito, swasong. So it's 60. Ang 80 pala ay 40 divided 2. Yeah, ito lang 2. So it's 4 times 20 divided. So 4 times 20. It's sort of based, hindi pala siya sexagesimal. It's based on 20s. So nagbibilang sila based on 20s. How many 20s? Since ang idea nila is there are 20 uh, on an average person, there are 20 fingers. Well, there are 10 fingers and 10 toes. So 20 in total. Next, the Chinese numeration system and the Hindu-Arabic decimal system. The Chinese numeration system uses an arrangement of small bamboo rods to represent the numbers 1 to 9. These were used as digits which were then placed in the units, tens, hundreds, thousands, etc. It is quite like the decimal system we use today. And finally, the Hindu-Arabic decimal system. The numerals we use today are attributed to Hindu mathematicians in the 6th or 7th century. Hindu numerals were adapted by the Arabs around 800 AD and gradually changed in appearance. To credit both originators and propagators, modern numerals are now called Hindu-Arabic numerals. So we'll focus more on the Hindu-Arabic numerical system. So a decimal number is formed when the symbols 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. We call them the decimal digits. Each position in a decimal numeral has a position value which is a power of 10. Each position to the left increases the position value. Each position to the left increases the place position value by a factor of 10. One position to the right. So as you go to the left, the place position value or increases by a factor of 10. One position to the right decreases the place position value by a factor of 10. So pag pupunta ka sa right, lumiliit by a value of 10. Pag pupunta ka sa left, lumalaki by a value of 10. Given the decimal number d sub n minus 1, dot, 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 d sub 0, decimal point d negative 1, dot, 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 d negative m, when expanded, it represents a real number equal to the sum d sub n times 10 to the power n plus d sub n minus 1 times 10 to the power n minus 1 plus dot, dot, dot times 10 to the power 0, which is equal to 1, plus d to the d of negative 1 plus 10 to the negative 1 power plus dot, dot, dot d sub negative n times 10 to the negative n, where the symbol d sub I for any integer I. So halimbawa, we have here 10, sort of, kunyari, you have here 108.25. Pareho lang ito sa 100 times 10 to the power 3. Oh, sorry, 10 to the power 2 plus 0 times 10 to the power 1 plus 8 times 10 to the power 0 plus 2 times 10 to the power negative 1 plus 5 times 10 to the power negative 2. So yan yung 108.25. So yan yung equivalent niya kapag in-expand siya. Okay? So the digits to the left of the decimal point form the whole or integral part of the numeral, whereas the digits to the right of the decimal point form the fractional or decimal part of the numeral. So ito yung decimal part, ito yung whole number part. Ito yung decimal point. So ito, nakalutang yung dot, dot, dot. Tapos ito, nakababa. Tapos dot, dot, dot na nakataas. So notice, pag tinignan nyo, hindi yan pantay yung mga dots natin. Bumaba ito, umakyat. Okay? So itong dots na to, naka-multiply siya. Ito naman, dot, dot, dot. Ito, multiplication. Ito, ellipsis. Okay. Other positional systems work the same way as the decimal system, include the binary system with numerals 0 and 1, the octal system with numerals 0 to 8, and the hexadecimal system with numerals 0 to 9 and letters A to F. So we will not delve in the conversion from, ayan, ito yung binary and hexadecimal system, but we will not delve into the conversion from binary, decimal, hexadecimal. So kung curious lang kayo, ito ang binary numbers, ito ang decimal numbers, ito ang hexadecimal conversion. Okay? So 000, ang binary, decimal 0, hexadecimal 0. 0001, decimal 1, hexadecimal 1. 0010, decimal 2, hexadecimal 2. 1010, decimal 10, hexadecimal 8. Again, we will not delve into the conversion. So if you are just curious, you can study them for fun. Okay? Or I can teach them if we have time kung ano ba itong mga conversion na ito. Okay? Now, we'll focus after ano ba itong real numbers and modular number systems. The development of real numbers began with the need to represent quantity, from natural numbers to rational and irrational numbers. And finally, so, nung nakita natin sa sets, dinefine natin ang natural numbers, and then lumaki sa rational, nagkaroon ng irrational numbers like square root of 2, pi, and finally, lahat ng real numbers. Numbers continue to develop as there is a continuous need for society to express new ideas through the use of numbers. So, we have the following system. The set of natural or counting numbers. The set forms the set of counting numbers. This set is also called the set of natural numbers and is denoted by the symbol n. Note that the set of natural numbers are set of counting numbers. We have here 1, 2, 3, and so on. Now, the set of whole numbers, the elements of the set of natural numbers, n, together with the number 0, form the set of whole numbers and is denoted by W. Note that W is equal to the set of natural numbers unit set containing 0. The set of integers, the set of natural numbers n, is also referred to as the set of positive integers denoted by z plus. So pareho lang itong dalawang symbol na ito. Now, for each element x in z plus, there corresponds a number negative x, which is called a negative number. We denote the set of negative integers by z minus. Note that the number 0, which is also an integer, is neither positive nor negative. When we combine the number 0 we combine number 0 with the elements of z plus and z minus, the set of integers z is formed. Note that z, we have the editing elements, dot, 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 negative 3, negative 2, negative 1, 0, 1, 2, 3, and so on. Now, the set of rational and irrational numbers. Medyo mahaba ito. A rational number is a number that can be expressed as the ratio of two integers where the denominator is non-zero. In other words, if a and b are integers and b is not equal to zero, then a over b is a rational number, basically a ratio or a fraction. We denote the set of rational numbers by q, q for quotient. A rational number can be expressed in fraction form or decimal form. We can differentiate rational and irrational numbers labeled as q prime based on its decimal form. The decimal expansion of a number is either terminating or non-terminating. It is terminating, it is a finite number of digits in its decimal portion. If a number in decimal form is terminating, it is automatically rational. On the other hand, a non-terminating decimal expansion can be rational or irrational. It depends on whether its decimal portion is repeating or non-repeating respectively. So kapag non-terminating at ito ay non-terminating at ito ay repeating, then it is rational. Pero pag non-terminating and non-repeating, so parehong non, ito ay irrational. For example, the set of integers are also rational. Typical examples of irrational numbers include pi, e, and square root of 2. Okay. And finally, the set of real numbers. The union of the set of rational and irrational numbers comprise the set of real numbers R. Together with the operations addition and multiplication, they form a special system that satisfy the following actions. So ang real number systems, pwede mo siyang samahan ng operations na addition at multiplication. If you combine them with the operation of addition and multiplication, we have the following axioms. The first one is closure. Anong sinasabi ng closure? Kapag nag-add ka or nag-multiply ka ng dalawang real numbers pa rin ang makukuha mo. A plus B and A times B are real numbers. Followed by commutativity. Commutativity says that A plus B is equal to B plus A and A times B is equal to B times A. Associativity. A plus B plus C is equal to A plus B plus C. And A times B times C is equal to AB times C. So, dito, kahit sino sa unahin mo sa dalawang ito, pwedeng ito muna i-group mong dalawa o i-group mo si A plus B. Associativity, na-associate mo yung mga factors or yung mga addends or yung mga terms. And distributivity of multiplication or over addition, A multiplied by B plus C is equal to AB plus AC, and B plus C times A is BA plus CA. So meron ka left distributivity at right distributivity. Yun ang sinasabi mo. So we have the following axioms. And then, importante, number 5 and number 6, huwag mo pagbabaliktad itong dalawang ito, mauuna muna ang existence of identity elements for addition and multiplication. Ano ibig sabihin ng existence of identity elements? Mayroon tayong pwedeng i-add na number 0 sa A such that ang makukuha natin yung A ulit. A plus 0 is equal to A. 0 plus A is equal to A. Sa multiplication naman, pag minultiply mo ng 1, A times 1 is equal to A, 1 times A is equal to A. So, identity, ito yung magbibigay sa'yo ng same answer ulit. Ayun, yung identity. Kaya ang identity siya na preserve yung identity nung real number natin. Kapag minultiply mo or inadd mo siya. And finally, existence of inverse elements under multiplication and addition. Sabi dito, pag nag-add tayo ng negative A, makukuha natin ng 0 At pag nag-multiply tayo ng A, ng 1 over A kay A, provided that A is not 0, makukuha natin si 1. Kaya dapat, nauuna muna dito yung number 0 at number 1 kasi i-represent natin sila na nag-exist na sila sa existence of inverse elements. So, laging nauuna ang existence of identity elements bago ang existence of inverse elements. At ang identity elements natin ay 0 and 1. Yan ang mga identity elements. Okay. Now, let's expand our horizon from the set of real numbers. We have the set of imaginary numbers. An imaginary number is a number multiple of I, where I is equal to root of -1. And finally, the set of complex numbers. A complex number is a combination of a real number and an imaginary number of the form z or z is equal to a plus bi, where ab is a real number and I is equal to root of -1. So, okay, so yun lang ang complex number. So, kung gagawa tayo ng hierarchy nito, you have here, oops, sorry. Nandito ang complex numbers. Tapos, nandito ang real numbers. Ang real numbers, it can be partitioned between the rational and irrational. Tapos, under irrational, nandiyan ang integers. Under integers, nandiyan ang whole numbers. And nasa baba ng whole numbers, natural numbers, and zero. Natural number, and the set containing zero. So, yun yung hierarchy ng decimal number system, ng complex number system. So, mas malakas. Ito yung family tree or a snapshot of their family tree. Okay. Let's go back to the set of natural numbers. Okay. Balik tayo dito. So, prime and composite numbers. Ano ang prime and composite numbers? A prime number is a natural number whose factors are 1 in itself. Composite number is a natural number that has other factors in addition, but that has other factors aside from 1 and itself. It is important to note that 1 is neither prime nor composite. Okay? Now, let's talk about modular number systems. Ano naman ang modular number system? So, iba naman ito from real number system. A modular number system ay mukha siyang natural numbers. Pero, ito yung generalization ng binary system, 0, 1. Generalization siya ng hexadecimal system, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Okay. Consider the following subset of whole numbers. Z sub n is equal to 0, 1, 2, 3, dot, 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 and minus 1. We refer to this set as the modular set containing n elements. We define an addition on the set as follows. So, ganito yung addition sa set na ito. A plus sub n is b is equal to r if and only if r is the remainder of a plus b when divided by n. Similarly, modular multiplication of elements of A of the set produces the remainder when the product is divided by n. So, halimbawa, Z2. Ito yung binary system. Ang Z2 may dalawang elements, 0, 1. So, ano itsura ng mga elements ng addition dito? So, 0 plus 0, 0. So, 0 plus 0 is equal to 0 divided by 2. So, kailangan mo i-divide by 2, no? 0 plus 0 is equal to 0. And then divided by 2, we get 0. Next, 1 plus 0. Sorry pala. 0 plus 0 is equal to 0. And then 0 divided by 2. 0, 0 times 2, 0, 0. So, ang remainder natin, 0. Ito pala, hindi pala quotient. Quotient ito. Ito kinukuha natin remainder. So, remainder is 0. 1 plus 0. 1 plus 0 is equal to 1. 1 divided by 2. 1 divided by 2, 0. 0 times 2, 0. 1 minus 0, 1. So, ang remainder natin, 1. 0 plus 1, ganun din, 1. 0 plus 1, 1. 1 divided by 2, 1. 0. 0 times 2, 0. 1 minus 0, 1. And finally, 1 plus 1. 1 plus 1 is equal to 2. 2 divided by 2 is 1. 1 times 2, 2. 0. So 0. 0 yung remainder. So 1 plus 1 is 2. 2 divided by 2. 1. Remainder 0. Paano naman yung product? 0 times 0, 0. 0 times 0, 0. 0 divided by 2. Ganun ulit, 0. 0 times 2, 0. 0. Remainder 0. 1 times 0, 0. So 0 divided by 0 divided 0 divided by 2. That would be 0, 0, 0. 0 times 1, 0. And 1 times 1, 1. 1 times 1, 1. 1 divided by 2. 1 divided by 2, 0. 0 times 2, 0. 1 minus 0, 1 minus 0, 1. Kaya 1. Let's look at another example, Z3. Z3, may laman siyang 0, 1, 2. So 0 plus 0, 0. 0 plus 1, 1. 0 plus 2, 2. 1 plus 0, 1. 1 plus 1, 2. 1 plus 2, 0. Bakit 0? 1 plus 2 is equal to 3. 3 divided by 3. 3 divided by 3. 1. 1 times 3. 3. 3 minus 3, 0. So 0 yung remainder. 2 plus 0, 2. So 2 plus 0 is equal to 2. Plus 2 divided by 3. 0. 0 times 3. 0. 2 minus 0, 2. Remainder is 2. 1 plus 2, 0. So basically, 1 plus 2, 3. Kapag equal yung number na yun dito, kumbaga, yung 3, siya yung nagiging 0 natin. So tingnan mo, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So kapag multiple ka ng 3, bumabalik ka sa 0. Dito naman, pag multiple ka ng 2, bumabalik ka sa 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So ito yung even, ito yung odd. And then 2 plus 2, 1. Bakit 2 plus 2, 1? 2 plus 2, 4. 4 divided by 3, 1 times 3, 3. 4 minus 3, 1. So dito naman, 0 times 0, 0. 0 times 1, 0. 0 times 2, 0. 1 times 0, 0. 1 times 1, 1. 1 times 2, 2. 2 times 0, 0. 2 times 1, 2. 2 times 2, 4. Saan ang 4? 4. 0, 1, 2, 3, 4, 1. That's another technique, counting. 0, 1, 2, 3, 4. So 4. Or 2 times 2, 4. 4 divided by 3, 1, 3. 4 minus 3, 1. Let's do one more. Z6. Z6, 0, 1, 2, 3, 4, 5. So, kunyari, titingnan natin yung 2 times 4. 2 times 4, you get 0. But 0, 2 times 4 is equal. Ay, bakit ako nga no? 2 plus 4 pala. Sorry. 2 plus 4 is equal to 6. 6 divided by 6. 1, 6. 6 minus 6, 0. So 0. 2, 5 plus 5 is 4. 5 plus 5 is equal to 10. 10 divided by 6. 10 divided by 6, 1. 6. 10 minus 6, 4. Okay? Fine. And so, 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. So, 2 times 4, 2. Bakit naging 2 times 4 ay 2? 2 times 4 ay 8. Okay. 2 times 4 is equal to 8. And then 8 divided by 6. 8 divided by 6 ay 1. 1 times 6. 6. 8 minus 6, 2. So remainder ay 2. 4 times 2 ay 2. How about 3 times 5? 3 times 5 is 3. 3 times 5 ay 15. 15 divided by 6. Ito ay 2. 12. 15 minus 12. 3. Remainder, 3. Okay? And finally, 5 times 5 ay 1. So 5 times 5 is 25. 25 divided by 6, that is 4. 24, 1 ang remainder. Okay? So that's how you do modular multiplication and modular addition. Now, Zn together with the modular operations plus sub n and dot on multiplication dot n forms a system like the real number system. It satisfies all axioms listed before except for the last one. Although okay, so hindi lahat, unlike sa real number na nag-e-exist, yung inverse, yung multiplicative inverse ng lahat ng real number na except 0, lahat merong multiplicative inverse na 1 over 8, hindi lahat may multiplicative inverse. So, halimbawa dito, 1 times 1, 1. 1 ang multiplicative inverse, 0 ang additive inverse. Bakit? 0 plus 0 is 0. 0 plus 1 is 1. So, nakuha natin yung original numbers na to kapag inad mo sa 0. Dito, 1 ang multiplicative inverse. 0 times 1, 0. 1 times 1, 1. So 0 times 1, 0. 1 times 1, 1. So 1 ang multiplicative identity. Okay, so in fact, ano sila? Ang 1 may multiplicative inverse, sarili niya. Ang 0 may additive inverse, yung sarili niya. 1 plus 1, 1 plus 1, 0. 0 plus 0, 0. Dito, ang Z3, 1 ang 0 again, ang additive inverse. 1 ang multiplicative inverse. So 0 plus 0, 0, 0 plus 1, 1, 0 plus 2, 2. And may may additive inverse. Additive inverse naman, 1 plus 2 is 0, 2 plus 1 is 0, 0 plus 0, 0. So ang 2 at 1, sila ang inverse ng isa't isa, additive inverse. Dito, ang additive inverse ni 1, 1 times 1, 1. So 1 times 1, 1. 2 times 2 is 1. 2 times 2 is 1. So, ang multiplicative inverse, di ba sa real numbers, 2 times 1 half is 1. Dito naman, 2 times 2 is 1. So, ang multiplicative inverse ni 2 ay sarili niya. Ang multiplicative inverse ni 1, sarili niya. Dito, ang multiplicative inverse ni 1, sarili niya. Additive inverse, so nakikita niyo, additive inverse, multiplicative inverse. Magkaiba yung dalawang yun. Pag additive inverse, 1 plus 1 is 0. Dito naman, 1 times 1 is 1. Ito kasi yung multiplicative inverse. Ito yung multiplicative identity. Ito yung additive identity. So ito yung multiplicative inverse of 1. Ito yung additive inverse of 1. Dito naman, 1 plus 2 is equal to 0. 2 plus 1 is equal to 0. So si 1, ang additive inverse of 2. Si 2, ang additive inverse of 1. 0 naman yung additive identity. Ito naman, 1 times 1 is equal to 1. 2 times 2 is equal to 1. So si 2, 2 is self-inverse ang tawag dyan. Self-inverse, o may tawag nga dito sa sa math, ang tawag namin sa math dito, idempotent. Idempotent, tapos yung 1, ito ay yung multiplicative identity. Sa Z6, so lahat may additive inverse, pero hindi lahat may multiplicative inverse. Notice dito, sa Z6, si 1, meron siyang multiplicative inverse, si 1. 1 times 1, 1. Si 2, 2 times, wala. 2 times, nakikita nyo, 240, 240. Wala siyang multiplicative inverse. Wala kang multiply sa 2 para makuha ay 1. Si 3, ganun din, wala. 3 times, wala. Si 4, ganun din, wala. Si 5, meron. 5 times 5 is 1. So ano yung technique para malaman kung kailan lahat ng elements mo may multiplicative inverse? Okay, here's a trick. Kapag hindi prime number ito, pag hindi ito prime number, hindi lahat merong multiplicative inverse. Tingnan nyo. Sa Z3, prime number ang 3, prime number ang 2, lahat may multiplicative inverse. Ito may multiplicative inverse, 1 and itself, 2 and itself. Dito, 1 and itself. Pero, kapag hindi ka prime number, may mga numbers ka na walang inverse. So, ang tanong, sino yung mga numbers na yon? Will turn out, yung mga numbers na yon, yung may common factor with 6. Si 6 ay may common factor with 2. 6 ay 3 times 2. 2 ay 2 times 1. So, may common factor sila. 3 ay 6. 3 times 2. 3 ay 3 times 1. Common factor is 3. 4. 6 ay 3 times 2. 4 ay 2 times 2. May common factor sila. 2. Pag may common factor kayo, apart from 1, automatic, hindi kayo, automatic, meron kang, wala kang multiplicative inverse. Kaya kapag prime number ito, Z13 halimbawa, lahat doon, lahat ng numbers, Z, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, lahat ng mga numbers dito, wala silang common factor with the number 13. May term kami doon ang tawag relatively prime. But we will not delve onto the terminology. Okay. So, saan ang gamit ng mga to? So, ang isang gamit nila is a cryptography. So, cryptography is a study of encoding and decoding messages. Two parties can send messages to and from each other in a secure manner with the aid of the modular system Z26. So, ang Z26 and 26 ay hindi prime numbers, so ibig sabihin hindi lahat may inverse. O hindi lahat may multiplicative inverse, which has 26 elements, the same number as the English alphabet. We assign the numbers 1 to 25 to the letters A to Y, and we assign 0 to the letter Z. This suggestion offers a more natural way of linking numbers to letters. However, there are other ways of assigning numbers to letters, and depending on its complexity, one could add another layer of security to the encryption, and of only those who know it is capable of decoding it. The second item needed to begin the process is the equation of the form y equal to ax plus b, where a, b are numbers in Z26 and a has a multiplicative inverse. In fact, dahil may multiplicative inverse si a, ang mga numbers lang na pwede dito ay 1, 3, 5, 7, 9, 11, 15, 17, 19, 21, 23, 25. Ito yung mga numbers na walang common factor with 26. Numbers between 1 to 25 na walang common factor with 26. Okay? So nakikita naman natin, no? Kaya kapag may common factor kayo, katulad dito, common factor, 2, 3, 4, may common factor kay 6, wala kang multiplicative inverse. Pero kapag wala kang, sorry, kapag may common factor ka with the subscript here, wala kang multiplicative inverse. Pero kapag wala kang common factor with the subscript here, meron kang multiplicative inverse. So, halimbawa, 1, anong multiplicative inverse ni 1 sa 26? 1 times 1 is equal to 1. Si 3, 3 times 3 times 23 yata. 3 times 23, tingnan natin. 3 times 23, 9, 69. 9, 69. 69 divided by 26. 26. Hindi yata. Hindi yata 23 ang inverse ni A. Inverse ni 3. Kung, tingnan natin. 3 times 25. 25 times 3. 5 times 3, 15. Carry 3. 3 times 2, 6. 75. 75 divided by 26. 26 times 3, 69, no? Hindi rin. Hindi rin 25. Baka 19. 19 times 3. 9 times 3, 18. Carry 1, 48. 26 plus 26, 52. Hindi rin 19. Baka 21. 21 times 3. 21 times 3, 3, 63. 63 divided by 26. 26. Mukhang hindi. 9 yata. 9. 9 times 3, 27. 27 divided by 26, 1, 26, remainder 1. Ayun. So ito ay equals to 1. Ayun, 9 times 3. 9 ang inverse ni 3. So, ganun din. Ang inverse ni 9, si 3. Ang inverse ni 3, si 9. Pair sila labo. Okay, how to encrypt messages. Convert the letter into its number counterpart. Substitute in the equation y is equal. So step 1, convert the letter into its number counterpart. Step 2, substitute in the equation y equal to ax plus b in place of x each value obtained in the previous step. Number 3, translate each y to its letter version using the same key step in step 1. The result is an encrypted message to be sent to the other party for them to decode. Okay. Oops. Here's an example. Okay, let me just check for an example. Walang example. Okay. So halimbawa, let's try to convert hello. Okay. Convert natin yung hello. So, hello, convert the letter into its number counterpart. Example, hello. Okay. Ano ang number counterpart niya? Number counterpart, so step one, hello is convert the letter into its number counterpart. Hello, 8, 5, 12, 12, 15. Tama, no? 15, OPQR. Tama. 15. Na okay. And then, substitute in the equation y is equal to ax plus b in place of x, each value obtained in the previous step. So yung a natin, simplihan natin. A, gamitin natin a ay 1. Okay. So, kunyari, step 2, gamitin natin para simple, y is equal to 1x plus, ano yung b naman natin? 1x plus halimbawa, b ay z26. So, any number sa z26, kunyari, 5, 1x plus 5. Or sige, para simple, 1x plus 3. So, ano makukuha natin? I-substitute natin yung bawat values na yun na nakuha natin dito sa y is equal to ax plus b. So, we get here x 8, 5, 12, 15. Ito naman, x plus 3. Y is equal to x plus 3. So, x plus 3, dapat ano, no? X plus 3 in terms of z. Ay, in terms of, is in z26. O sige, para interesting naman, wag 3. Gawin natin tong plus 25 or plus 10. So, in z26. Okay. Or, para interesting, 3x plus 1. Ayan. Okay. 3x plus 1. So, 3 times 8, Oops. 3 times 8, 24, plus 1, 25. So ito ay 25. 5 times 3, 15, plus 1, 16. 12 times 3, 12, 24, 36, 37. 37 divided by 26, 1, 26. So this is 1, 1, 11. And 15 times 3, 45, plus 1, 46, divided by 26, 1, 26, 6 minus 6, 0, 20. Okay. And so finally, translate each y to its letter version using the same key in step 1. So step 3, ang meron tayo ay 25, 16, 11, 11, 20. Ano ang 25th letter? 25th letter is K, Y. 16 is O, P. 11 is uh, K. K. 20 is OPQRS T. So that is hello in our encryption 3x plus 1. Yeah, good. Okay. Okay. So the next one is, paano pag given tayo ng YPKT, KKT? So, ida-decrypt naman natin siya. Decrypting. So, step 1, convert every letter into its, babaliterin natin. Step 1, Y, P, K, K, T. So, convert natin 25, 16, 11, 11, 20. Tapos, solve for X in the encrypting message. Saan ang galing ito? Nanggaling yan sa Y is equal to AX plus B. So, Y minus B is equal to AX. Tapos, X is equal to Y minus B over A. Kaya A inverse times Y plus negative B. Yun yung dahilan kung bakit dapat may inverse si A. So where A inverse is the multiplicative A of Z26 and negative B is the additive inverse of B in Z26. So, meron tayo dito, step 2. So meron tayong Y is equal to 3x plus 1. Makukuha natin Y minus 1 times 3 inverse Y, or this would be 1/3 times Y minus 1 is equal to X. Or this is just X is equal to 3 inverse times Y plus negative 1. Ano yung nakuha nating 3 inverse kanina? 9. Yan yung ano niya, no? Inverse ng 3, no? 3 times 9 is 27. 27 divided by 26 is 1. Tapos ano yung additive inverse ni 1? Ano yung i-add mo kay 1? Ano yung i-add mo kay 1? 1 plus, para makuha ay 0. 1 plus 25. 1 plus 25 is 26. Divide by 26. 26 divided by 26. 1. 1 times 26. 26. 0. So ito ay y plus 26. So ito ang ating decoder. So, step 3 na tayo. Kailangan bumalik yung hello. So, meron ka ditong X. Okay. Y, P, K, K, T. Tapos, X is equal to 9. Sorry. Y pala ito. Sorry, class. Y pala ito. X is equal to 9 times Y plus 26 in Z26. Okay. So we have here, YPKKT. So ito ay 25, 16, 11, 20. Okay. So 25 plus 26, we get there. 25 plus 26, that would be 51. Divided by 51 divided by 26, we get there 1, 26, we get 25. So, 25 yung ano natin. 25 yung, sorry, 25 pala ito. Ito ko 26, 25 pala yan. 25. So, 25 plus 25, 50, divided by 26. 50 divided by 26 is 1, 26, 24. 24. So we get 24 times 9. 24 times 9. So 9 times 24 is equal, dito na lang, sulat ko na lang, 9 times 24, 9 times 24, 4 times 9, 6, 24 times 9, 9 times 4, 36, carry 3, 18 times, 18 times, 18 plus 3, 21. 216 divided by 26. 26 times 8, siguro, no? 8. Hindi. 26 times 10. 9. Sige, 8. Subukan natin ng 8. 6 times 8, 4. 48. Carry 4, 16. 17, 18, 19, 20. 208 na natin. 8, 208, remainder 8. 216 sa 8. 16. 16 plus 25. 16 plus 25. 6 plus 5, 11. Carry 1. 41 divided by 26. 26 divided by 41. 1, 26. 11 minus 6, 5. 3, 3 minus 2, 15. So 15 times 9. 15 times 9. So pwede nyo munang liitan ito. Pag naliitan nyo ito, pwede munang, kasi 9 times y plus 25 divided by 26. Pwedeng i-divide mo na ito by 26, and then pag natapos kayong mag-multiply, i-divide nyo pa in 26 pagkatapos ko doon. So 9 times, ano yun? 16 plus 25, 41. Pero 26. 26. Ito ay 1, 26, 5 carry 1, 15. So 15 times 9, 5 carry 4, 25, 9 plus 4, 13. 135 divided by 26. Let's try 2, 4, 6, 2, 4. 26 times 4, 6 times 4, 20, 6 times 4, 24, 8, 9, 10. So 5 siguro, 5. 26 times 5, 6 times 5, 30, 33, 5 times 2, 10, 11, 12, 13, 135, remainder 5. 11. 11 plus 25, 5 plus 1, 6. 5 plus 1, 6. 2 plus 1, 36. 36 divided by 26, 1, 26, 10. 10 times 9, 90. 90 divided by 26. Let's try 26 times 4. 26 times 4, no? 24, therefore 8 na ang hindi, sobra. 3. 26 times 3. 26 times 3 is 18. 6, 78 to 78. 90 minus 78, 12. And finally, 20 plus 25, 5, 45 divided by 26, 1, 26, 15 minus 6, 9, 19. 19 times 9, 81, 1, carry 8, 9 plus 8, 17. 171 divided by 26. Let's try 9, and then 8, 7, 7. 26 times 7, 6 times 7, ay 42. 42, 2 carry 4, 14, 14 plus 14 plus 4, 18, sobra. So 6. 6 times 6, 36, carry 3, 12, 13, 14, 15, 156. So kung ito ay 656, 10 minus 6, ay 11 minus 6, 5, 7, magiging 6. 6 minus 5, 15. 0. 15, remainder 15. And so, pag kinonvert natin ito, step 4, you have 8, 5, 12, 12, 15. Ang 8 ay H, ang 5 ay E, ang 12 ay L, ang 12 ay 15. Bumalik. Hello. Okay. So, medyo matrabaho tong YPKKT, no? Okay. Now, we now go to mathematics as a science of patterns. So, number patterns. Kanina natin ano yung mga number patterns? Number patterns are among the patterns we first learned in school. We were taught to detect a connection in a number sequence and use this knowledge to determine the next part of the sequence. Generally, one can apply this skill to make educated predictions like the way we do in science. In a way, understanding patterns support the development of mental skills and is vital to every individual. Okay, so Halimbawa, Fibonacci numbers. Fibonacci numbers and the golden ratio are considered magical values in the sense that they consistently and inexplicably appear in nature, like leaves, flowers, fruits, and shells. Ano yung Fibonacci sequence? So, Fibonacci sequence, ito yung 1, 1, 2, 3, 5, 8, 13, 21, 34, 55. So, 1 plus 1. So we start with 1 and 1. 1 plus 1, 2. 1 plus 2, 3. 2 plus 3, 5. 3 plus 5, 8. 5 plus 8, 13. 13 plus 8, 21, and so on. And then we have the golden ratio phi. Golden ratio phi is 1 plus square root of 5 over 2 is approximately 1.618033988,749. Okay. So, ano yung isang idea dito ng, ng golden ratio Fibonacci numbers? So, saan siya lumalabas? So, kapag ginawa natin yung tinatawag na Pascal's triangle, okay, okay. So, Pascal's triangle, you start with 1 sa taas, okay. Oops. So dito, 1, and then followed by 1 and 1, tapos 1, 1, tapos 1 plus 1, 2, and then 1 ulit dito, 1, 1, 1, sorry, 1 plus 2, 3, 2 plus 1, 3, and then 1 ulit, 1, 1 plus 3, 4, 3 plus 3, 3 plus 3, 6, 3 plus 1, 4. Continuing, we have here 1, 5, 10, 10, 5, 1, 1, 15, 5 plus 10 ay 15, ay sorry, 1 plus 5 ay 6, 15, 20, 15, 6, 1. So an application of this is yung decimal expansion. Halimbawa, we have a plus b squared. We have 1a squared plus 2ab plus b or plus 1b squared. Or this is a squared plus 2ab plus b squared. Ito yon. Ano yung a plus b cube? A plus b cube ay 1a cube plus 3a cube, a squared b plus 3ab squared plus 1b cube. Ito naman yun. So you can guess ano ang a plus b to the power 4. A plus b to the power 4, yan ay 1a to the power 4 plus 4a squared, a cube b plus 6a squared b squared plus 4ab cube plus 1b to the power 4. And so on. Yan ang decimal expansion. Furthermore, you can see here yung na yung diagonal natin dito Okay. So this diagonal here is 1. And then mhm, this diagonal here is 1. This next diagonal is 2. This diagonal here is 3. This diagonal here is 5. This diagonal here is 1, 4. 3, 1 is 8. And then followed by 1, 5, na ano ako. So yung diagonal ay 1, 4, 3, 1, 4, 3 pala. Hindi matatamaan itong 1 na ito. And then this green here, or this light blue na lang, 1, 5, 6, 1. That would be 6 plus 5, 11, 12, 13. So nakikita ninyo, Fibonacci sequence ito. 1, 5, 1, 1, 2, 3, 5, 18. So lumalabas yung number natin. And then, furthermore, 1 divided by 1, 1. 1 divided by 1, 1. 2 divided by 1, 2. 3 divided by 2. So, dito, 1 divided by 1, 1. 2 divided by 1, 2. 3 divided by 2. 3 divided by 2. 3 halves or 1.5. 5 divided by 3. So, let me share this screen. Mhm. Okay, this is from aperiodical.com. So ito yung website natin. So nakikita nyo dito, 1 divided by 1, 1. 2 divided by 1, 2. 3 divided by 2 is 1.5. 5 over 3, 1.666. 8 over 5. So 8 wala dito, no? Ito, 8 over 8. 8 over 5, Fibonacci. 8 over 5 is 1.6. 13 over 8 is 1.625. 13 over 8 is 1.625. 21 over 13 is approximately 1.615384. 34 over 21 is 1.619047. 55 over 34 is approximately 1.617647. So lumalapit sila ng lumalapit sa golden ratio. Yung golden ratio natin ay approximately, saan yun? Uh-huh. Where is that golden ratio? golden ratio is ito, approximately 1.618033. So, yung ratio ng bawat Fibonacci numbers, palapit ng palapit. And na-visualize natin sila using the Pascal's triangle. So again, yung ratio natin dito, Pascal's triangle yung nakukuha natin. Yung ratio ng bawat number, it approximates the golden ratio. Okay, and finally, symmetry and phase patterns. Symmetry is not only prevalent in mathematics, but also in nature, art, and design. We observe symmetry in Pascal's triangle and binomial expansion in butterflies and snowflakes. So ito, meron tayong, napansin niyo sa binomial expansion kanina, may symmetry daw. 1, 2, 1. 1, 3, 3, 1. May mirror symmetry kayo nakita. 1, 4, 6, 4, 1. So dito rin may symmetry na nakikita sa triangle nito. And sculptures like oblation. Note that the ideas used in studying symmetry are not exclusive to mathematics. By considering symmetry in a wider context, we can realize the interconnectedness of mathematics with other disciplines. So ito yung mga iba't ibang symmetry. So given a figure, we say that a figure has a reflectional symmetry if points of the figure are equally positioned above the line. This line, if it exists, is referred to as the axis of symmetry. The axis of symmetry separates the figure into two equal parts and serves as a mirror or mirror to half the figure. Below are examples of symmetry found in nature. So ito, meron kang mirror symmetry. May mirror line ka dito. Ito yung mirror line natin. Mirror line. Kaya siya reflection of symmetry. May reflection ka. Nire-reflect mo ito sa part na to. Ito naman sa butterfly, meron kang mirror line dito. Ito, may symmetry ka dito. Okay? Now, it is also possible to have several axes of symmetry. The starfish has 5 arms, which also have 5 axes of symmetry aligned with each arm. The snowflake, on the other hand, has 6 axes of symmetry, 3 of which are aligned to each pair of extremities and the other 2 located in between the extremities. So for example, ang starfish, meron siyang symmetry dito, may symmetry rin siya dito sa dito rin, may symmetry siya. May symmetry rin siya rito. May symmetry rin siya rito. So, 5 yung symmetry. 5 yung mirror lines niya. 1, 2, 3, 4, 5. Okay. Or you can say na meron siyang 1, 2, 3. Sorry. Ito pala yung ano. 1, 2. Ayun. 2, 3, 4, 5. Ang snowflake naman, meron siyang, actually, meron siyang 12. Ito, 6 lang pala. 2, 3, 4, 5, 6. May 6 mirror lines siya. So, 1, 2, 3, 4, 5, 6. Okay? So, kapag odd yung arms, 5 lang. Pero kapag even, nakasama pa yung, kasi dito, ito yung axis, dumadaan siya dito sa gap. Dito, axis to axis. So, gap is to gap. Dito, axis, gap. Kaya naging nadoble yung symmetry. Now, radial symmetry or rotational symmetry. An object has rotational symmetry if points on it are uniformly situated around a point that serves as center of the object. A figure with rotational symmetry appears the same after rotating by the same amount around the center point. So halimbawa, ito, wala itong wala itong radial symmetry kasi mukha siyang may mirror line pero um, wala siyang mirror line kasi kung lalagyan mo ng mirror line dito, dapat ito, ang itsura ng ang itsura niya dito pag ganito. Pero notice pag ganito rin yung itsura. So rotation ito. Okay? Rotation na lang meron tayo. So dahil rotation na lang meron tayo, ang tanong, ito yung center natin, ano yung angle of rotation na? Or after how many rotations, bumabalik tayo sa original position. So, or ano yung pinakamaliit na rotation para ito, pupunta lang siya sa position na ito. Ito naman, pupunta sa position na ito. Ito, pupunta sa position na to. So, mareretain mo yung image. Pag nirotate mo siya, nare-retain yung image nung, I don't know if it's an octopus or a starfish. So, may tinatawag tayong order of rotation or angle of rotation. Ang angle of rotation is the smallest angle that would preserve the figure when rotated. So, ano yung angle of rotation? Yung pinakamaliit. So, para mahanap mo ito, bilangin mo yung tentacles. So, rotational symmetry object with a rotation theta degrees has ano yung order niya? Pag sabi ng order, ito yung dami ng bilang para bumalik tayo sa 1 or para makuha yung 1 revolution. So, di ba 360 degrees? 360 degrees is equal to theta times n. N yung order, theta yung angle of rotation. So, ano yung order natin para makuha yung 360? For example, ito, 1, 2, 3, 4, 5, 6, 7. So, 7. So, 7 ito. Itong n ay 7. After 7 rotation, di ba? After 7 rotations, babalik ka sa original position mo. So, 360 divided by 7, yan ang angle of rotation natin. So, dito, 360 is equal to theta times n. N yung order. Theta yung smallest degree natin. And then finally, we have translational symmetry. An object is translationally symmetric if it can be drawn its entirety by taking a portion of the figure and shifting it along axis. An example of translational symmetry can be seen in the way leaves are aligned along our branches of plant. So ito, yeah, you can say na meron din itong mirror line. Pero hindi mo natin papansin yan. Ito may translation siya. Ito, itatranslate mo papunta dyan. Ito yung leaf na yan. Ito, itatranslate mo sa leaf na yan. Ito, itatranslate mo sa leaf na yan. Ito, itatranslate mo sa leaf na yan. In fact, itong branch na to, buong branch, pwede mo pa i-translate up, up, and up. So parang mayroon kong dalawang translation. May translation kang papunta rito, may translation kang papunta doon. Another one is honeycomb. Yung honeycomb, nakikita mo, itong honeycomb, itong hexagon na to, may ta-translate mo siya papunta rito, pwede mo siya i-translate papunta doon, pwede mo pa siya i-translate papunta doon. So, translational symmetry. And in fact, translational symmetry, infinite order. Kumbaga, sa rotation, pwede mo sabihin, after finite number of turns, babalik ka na sa original position mo. Pero ang translation, forever yan. Forever siyang lumalipad. It goes that way. And it also goes that way. Pwede rin pa ganyan. Pwede rin pataas. Okay. Now, ano naman ang freeze patterns? Freeze patterns ay pag pinagsama-sama natin yung translation, reflection, rotation all together. Okay? Pag pinagsama-sama natin yung mga yun, so a strip with a symmetric pattern is called a phase pattern. There are 7 possible phase patterns provided that the design only has one color. Now, we will not delve into anong 7 phase pattern ito. Each pattern is a combination of reflection, rotation, and translation and symmetry. Okay, so may 7 phase pattern. Ang phase pattern, iba siya sa tinatawag na wallpaper pattern. Ang freeze pattern ay ano lang siya, strip lang siya. Strip lang. So, halimbawa ng mga uh, freeze patterns, ito. So, if you have, I have this book, Talents and Patterns. Uh, okay. Ito ang mga halimbawa ng, okay, strip patterns. So, if you can see here, itong mga to, strip lang yan. Strips. Okay, so there are, I think there are 7 of them. 1, 2, 3, 4, 5. Medyo marami. So, strip patterns lang sila. Oo. Strip patterns lang. So, kumbaga, isang strip, isang line lang sila. As opposed to wallpaper patterns na ganito ang itsura. Okay. Wallpaper patterns. Pag strip patterns, isa na yung translation niya. Ang translation niya, it goes this way lang. Isang translation lang. Ayan, etong pattern na ito pumupunta dito, itong pattern na ito pumupunta dito. So ito naman, ito yung pattern, no? Isang translation lang. Pero kapag wallpaper naman, may translation pa akyat dito, may translation papunta doon. So may dalawa kayong translation. Okay? May y-axis, x-axis. Sa freeze patterns, isa lang. X-axis, x-axis lang. Or pwede ring y-axis lang, pataas lang. Okay? So yun ang pagkakaiba ng wallpaper sa freeze. So pag narinig nyo lang, oh, my wall has a freeze pattern, strip lang siya. Okay? And that's it.